Hello class, today we are going to dive into section 1.5, rational numbers. The first thing we'll need to do is find out what a rational number is. A rational number is any number that can be written as the quotient of two integers where the divisor is not 0. A rational number is essentially any number that can be written as a ratio or a fraction. Please take a moment to pause this video and write down the definition of a rational number. Now I'd like to look at a few numbers and see if you can determine whether or not they are rational numbers or not. Let's do a few together and then you'll pause the video and try a few on your own. -1/4 is a rational number. It is written as a fraction or a ratio of two numbers. 0.3 repeating can be written as the fraction 1/3. Therefore, 0.3 repeating is a rational number. -3.030030003 is not a rational number. Although it does have a repeating pattern, this number cannot be written as a fraction or a ratio of two numbers. Therefore, it is not a rational number. Please take a moment to pause the video and try the next four numbers on your own. The number -3 6/7 can be written as an improper fraction of -27/7. Since this number can be written as a fraction or a ratio of two numbers, it is a rational number. 3.12345 again has a repeating pattern. The decimal would keep going up by one number, but it cannot be turned into a fraction or a ratio of two numbers. Therefore, it is not a rational number. 6 can be written as a fraction of 6/1, therefore it can be written as a rational number. Same with 0. Any whole number is a fraction over 1, therefore every whole number is a rational number. Now let's talk about comparing rational numbers. To compare rational numbers, you need to turn both numbers into either decimals or fractions with common denominators first. Please take a moment to pause this video and write down the process of how to compare rational numbers. Now let's try comparing a few rational numbers. The first example is very easy. Both numbers are already written as decimals for us, so all we have to do is think about the numbers on the number line. -3.2 or -3 2/10 is further to the right on the number line than -4 6/10. Therefore, -3 2/10 is greater than -4 6/10. In the next example, we need to turn either 2/3 into a decimal or 0.75 into a fraction. Either way is acceptable and will lead you to the correct answer. I think in this case it's easier to turn 2/3 into a decimal. 2/3 is 0.6 repeating. Once we turn it into a decimal, it's easy to see that 75/100 is larger than 2/3. Now please take a moment to pause this video, put the first two examples in your notes, and try the next two on your own. In the next example, both numbers are already written as fractions, but they don't have a common denominator, so we need to find a common denominator. The common denominator between 5 and 10 is 10, so we turn 3/5 into 6/10. Now it is easy to see that 7/10 is greater than 3/5. For the last example, we need to compare 123 thousandths to 1/8. While it is fairly easy to turn 123 thousandths into a fraction, it's not simple to find a common denominator between 1,000 and 8, so it is easier to turn 1/8 into a decimal. Remember to do this, we divide 8 into 1. 8 doesn't go into 1, so we add our decimal and add a 0. 8 does go into 10 once, so we subtract 8 from 10 and we get 2. Add another 0 and bring it down. 8 goes into 20 twice. 8 times 2 is 16. We subtract it and we get 4. Add another 0 and bring it down. 8 goes into 40 5 times. Therefore, 1/8 as a decimal is 0.125, or 125 thousandths. From this point, it is easy to see that 1/8 is larger than 123 thousandths. Now that we know how to compare rational numbers, we can also order rational numbers. To order rational numbers, you first need to do the same step as comparing them. Turn all of the rational numbers into decimals or fractions with common denominators. Please take a moment to pause this video and write down the process of how to order rational numbers. Now let's try an example together. Order these numbers from least to greatest. All of our numbers are already written in fraction form, so it's going to be easiest to compare them if we write them all as fractions. If we look at all of our denominators, our least common denominator is 24. So we want to turn all of our fractions into 24ths. 7/6 can be turned into 24ths easily, but it would be better to turn it into a mixed number first. 7/6 is 1 1/6, which is equal to 1 4/24. 11/12 is equal to 22/24. Now it's easy to see what order our numbers go in from least to greatest. Our smallest number is 11/12, then 14/24, 1, and the largest number is 7/6. Please take a moment to pause this video and record this example in your notes and try the next example on your own. In our last example, we have a mixture of decimals and fractions. You can turn all of the numbers into either decimals or fractions first and then compare them. Either way is perfectly acceptable and fairly easy to do. I'm going to turn all of them into decimals. 3/2 I first want to turn into the mixed number 1/2. 1/2 as a decimal is 1.5. Then I need to turn -3/4 into a decimal. -3/4 is equal to -75/100 as a decimal. Now that all my numbers are written as decimals, they're easy to compare, and it's easy to see that written from least to greatest, they would go -1, -3/4, 25/100, and 1 5/10. Now that you know what a rational number is and how to compare and order them, before you finish your notes, I want you to write down your own definition of a rational number. Please be prepared to come into class and share your definition.